squared. You understand? Yes? Alright, let me write that down so we can work it out as we go. So we had sine of 4x to the third. So my derivative should start off like we said, the derivative of the outermost layer. So 3 sine of 4x, right? Squared. Are we okay? Everybody understand that first step?
Yes.
Second step, what do you think we're going to do? What do we have to deal with now? The next layer, right? Which is the candy shell, which is sine of 4x. So what you're going to do is you're going to multiply the outcome, which is what I got up here, by the derivative of the next layer. What are we not going to touch now? So don't touch the gum. Yeah? Okay, so now we're going to multiply this outcome by the derivative of the next layer, which is the candy shell, sine of 4x. So what's the derivative of sine of 4x? Cosine of 4x. We can't touch that gum, right? Understand? What do you think the last step is to do? Do we have another layer? Yeah. So continue to multiply whatever you got by the derivative of the next innermost layer until the last layer is dealt with. Okay, so do I have another layer to deal with? We deal with this one, we deal with the sine. Is there one more? The bubble gum, right? So what, all of this times the derivative of 4x, which is what? 4. Did I find the derivative of each layer individually? Derivative of this was 3x squared. Derivative of that, cosine, right? Derivative of that, 4. We dealt with each layer from the outside in, and then we just simplify. So my derivative here, we can multiply the 4 and the 3, right? What will that give me? 12 times sine of 4x squared times cosine of 4x. That would be the derivative of that composite function up here. I didn't give it a name, but we could call it j of x if you want. I shouldn't have labeled it f. Well, let's give it a different name. Let's call it j of x. Good? You understand? Work from the outside in. You want to try another example? Let's try one, okay? So let's say I ask you to find the derivative of this composite function. What is it? 2x plus 3 to the third. How many layers does it have? 2. It has this exponent, right? And then it has this inner layer. This is like an M&M without peanuts, right? It has a candy shell and then it has chocolate, right? So let's do it. Do you want to experience that? Have some M&Ms.
I wasn't sure if you were going to do it.
No way! Alright, so let's find the derivative of this guy.
Are you sure you're just playing and you actually do have to?
No, I don't have
He
it.
actually has M&M.
You just pulled a bunch of M&Ms out of his pocket.
Imagine. Alright, so what would we do here first?
That's your future.
Derivative of that outside layer. So that would give me what? 3 times 2x plus 3 to the second. We're not done. Times the derivative of the inner layer, which is 2. And now we're done because there's no more other layers to do. And this could be rewritten as 6 times plus 3. Easy? How are we going to know when to use the chain rule? Can you see a problem and already have an idea I'm probably going to have to do chain rule? You think so? Most of the time, if it's something to a power, right? Yes? That's when you will use it. Because you have to do one layer and another layer and another layer. Sometimes there's 3 layers, sometimes there's 4, sometimes there's 100. That would be 100 derivatives multiplied with each other. That would be fun, right? I'll work on that one. I'll make that a bonus on the test. 100 composite functions.
Are you gonna give us the paper for it?
Alright, 10 minutes is good.
And you only have 5 minutes. Man, the answer is 1. That would be fun,
Is it
right?
quiz tomorrow?
Quiz tomorrow, okay? We can move it up if you want. I was planning on waiting till Friday, but
Oh, no, yes, that's
if
fine.
you're eager and you feel ready, we can
What
reschedule.
if we're not gonna be here on Friday?
Oh, you won't be here? Well then,
Can we come take it Monday morning?
I guess that would be an option.
Yeah, we are.
Where are you guys going?
No, yeah, but aren't you guys going to the competition?
You have the game?
We need to have
Well, you can come take it during second block then. You don't have to eat lunch, you can eat lunch on the bus.
Oh, yeah, that's true.
Huh?
Yeah,
You said not to buy it?
I wake up.
I'm not even able to send that one, but
I always buy it.
I mean, at least so you don't miss the quiz.
What?
And then you're gonna have to come take it after school, and then you start telling me, oh, it's because I have practice. And I can't come after
Okay, I'll go
school.
to lunch.
Right?
I just stormed out so fast.
But I mean, it is your personal choice. And that's a tough derivative, isn't it? That candy shell? That's a hard one to get through.
I didn't bid it.
Oh my god, you already did it all?
I'm gonna wait.
Ah. Did I give you guys a copy?
Like you guys are gonna be either. I was like, how did you know? I was like, I don't know where you're going.
Yeah, now we need actual fun, exciting notes. Cause like that lollipop thing was like, oh my god. That was like so childish. I'm sorry I did that. It's okay. Forgive me. I'll forgive you for it. If you choose to, my son, you may go.
I can feel the gum. I made it.
Alright, so now let's do some big boy notes. Okay? So let's look at this problem. It says 2x plus 3 to the third. Oh my god, didn't we just do that one?
Yeah.
And it says, as a function, in polynomial form. So how would I rewrite that in polynomial form? 1, 3, 3, 1. So you want to use the Pascal's triangle?
Huh?
No? Some people want to use Pascal, some people don't. What should I do? What is Pascal? You forgot about him, huh? How can you forget about
They
Blaise?
erased it for the.
About what? What's
About Blaise?
Really?
That's his name?
Yeah, Blaise
Oh yeah.
Pascal.
Yeah,
Why is that bad? Because he's blazing?
yeah.
We will have I'm going to give you guys an activity where you'll be assigned a mathematician and you have to learn about him.
That's actually
Kind of falls right into place for Dia de los Muertos. And
Final
things like
exam.
You can make a tombstone for each.
Can I get Fairmont's? Can I do one
Yeah?
for
Who wants Newton? Okay, good.
I want this.
Yeah, it's like no teacher.
And then we can make like a timeline and have all their tombstones.
Mm.
Alright, anyway, so that way they know we don't forget about it. What does 2x plus 3 to the third mean? 2x plus 3 times 2x plus 3 times 2x plus 3, right? So you want to do that? Or you wanna use what Blaise Pascal discovered for
I'll
us?
do a blaze.
Yes.
We go with Blaise?
Yeah.
I want to use the
Alright.
blazing
Let's go
triangle.
with Blaise.
Let's blaze.
So, Blaise Pascal developed a method for expanding a binomial. So let's do it. He used this Pascal's triangle that starts off with a 1, and then it's a what?
1,
1, 1, and then
1,
1, 2, 1, and then 1, 3, 3, 1, which is the row we need, okay? Because this is actually row 3, because we start with row what?
0.
0. So we need row 3, which is the 4th row, but it's row 3. Play on words anyways. So row 3, because it's something to the 3rd power. We ready? Alright, now all you have to do is use those as your coefficients with each individual term. So we write down parentheses, parentheses, 2x, right? 3, and we put the 1 in the front from there. Plus 3, parentheses, parentheses, what goes in there? 2x and 3 again. Plus 3, parentheses, parentheses, 2x and 3. Plus 1, parentheses, parentheses, 2x and 3. Are we okay? What power does the 2x first parentheses begin with? No? 3, and then we go down by 1 up until we get to 0. Then we come back up with the other guys. So 1, no. We start with 3, then 2, then 1, and then 2. Are we okay so far? Anything to the 0 power is what?
0.
Not 0, come on, you guys are in calculus.
1.
1,
That's fine.
A real quick question, why do you separate the 3 from the 2x? Like, why do you separate the function?
what do you mean?
Like, it's a 2x plus 3, and then you separate them into,
Well, because this is considered like A and this is considered B.
okay,
They're considered like individual terms, and when you expand it, that's the formula. So it's like 1AB, 3AB,
okay.
3AB.
So that's just what Pascal does, that's
Right.
part of it, okay.
Yeah, that's part of the formula, is the expansion. If we were to multiply it all out and do it, we would get something that looks like
Okay.
it. Okay? So now we actually have to expand each one. So what's 2x to the third? 2x times 2x times 2x? 8x to the third times 1? 8x to the third. 2x squared? That's 4x squared times 3 times 3. That's 4x squared times 9. So 36x squared. This is 2x times 3 times 3 squared. So 3 squared is what? 9 times 3? 27 times 2? 54. So plus 54x. And then we have 3 to the third over here is what? 27. Times 1 is 27. And we're done. How was that? Was okay? Or do you want to do it the other way? You can do it the other way too. Just so you can see which one was easier. Yeah? Yeah? Well, you can do it like that, I don't want to. Good? So now we have it expanded, now we can get its derivative. So what would the derivative be? 24x squared plus 72x plus 54. Yeah, we did the square, so 3 squared is 9, times 3 is 27. Good? Alright, so remember those two mathematicians, Leibniz and Newton? Right, the fathers of calculus? Well, between them two, Leibniz was the first of the two to use the chain rule, okay? So what I'm going to do is I'm going to write the chain rule, and then we're going to practice it a little bit, okay? We kind of already know what to do, right? So if h of x is equal to f of g of x, So notice that it's a composition of a function, right? Then the derivative of h would equal what? What do I have to get the derivative of first? The outer layer, which would be? So f prime. Do I change anything in the guts? No. Times the derivative of the inner layer, which would be g prime of x, times the derivative of the next inner layer, which is x, which is 1. Do we understand? Yeah? So we have the gum, we have the candy layer, g of x, and then we have the wrapper, f of x. Got it? An easier way to think of this is like this. So let's say I say h of x is equal to f of something. The derivative is going to be what? F prime of something times? Nope. The derivative of something, right?